Welcome to my blog on big data and cybersecurity. My name is Lipyeow Lim. I'm a computer scientist, an educator, and a software engineer. Today, I'm going to talk about insider threat risk. In particular, I'm talking about a statistics-based anomaly detection method for insider threat data exfiltration. Of course, we know that the main issue with insider threats for enterprises is actually data exfiltration. And there are really two separate cases for the data exfiltration problem. One is what one of my colleagues called the loud and proud, which is a big data dump in a single event. And this is actually relatively easy to detect with sort of conventional systems or technology using just a detection rule. The second case is the low and slow, and this is the harder one. This really means the threat actor is trying to cover their tracks. They are trying to do small data dumps over multiple events, sometimes over multiple modalities over long periods of time. So this is much harder to detect, and is what we're going to address in this notebook. So this is the setup. We're going to have four different data sources, and we're going to extract events from these data sources. Right. I'm not going to go into details of the event extraction process, but we're going to extract file copy or file write events from endpoint logs. These are basically events where a user is writing a file or data to an external media like a thumb drive. And then for the email side, we're going to extract those from the email logs, the mail server logs, just going to extract basically how much data is a user emailing out into external accounts, non-company accounts. And then for web events, we're extracting from the HTTP logs, the file uploads to websites, file uploads to say a Google Drive or to a Microsoft OneDrive, or to an external Dropbox. For example. For print events, this is where the threat actor is potentially exfiltrating data by printing to paper hard copies. And so this could be a way of exfiltrating data as well. Now, we're going to call these four different types of events modalities. These are modalities in which the threat actor will exfiltrate data. And what we're going to do is we're going to create baselines for each of these modalities. In fact, this is the really cool part. We're going to create baselines for each user and each modality, right? So basically, if your organization has 100,000 employees, we're going to create 400,000 baselines, one for each user and each modality. Now, with these baselines, we are then going to look at the user activities and detect anomalies, right? Basically, deviations from the baselines, right? So we're then going to count the baselines for each of these modality and combine the counts into a risk score for each user, for each employee, essentially. And the particular model that we're going to be using is a fairly simple one. I'm just going to go down and with this diagram, we're just going to use a Gaussian or a normal distribution. So the idea here is that many real-world events can be modeled as a normal distribution, especially when the sample size is sufficiently large. By the way, the normal distribution is represented by a bell curve. So this is the frequency distribution or the density distribution, where the peak of the bell is where the average or the mean value is. So typically, anything that is above 3 standard deviation or less or below by 3 standard deviations, those have about 0.1% of occurring. And so we're going to use the 3 standard deviation as a way to measure how much an event is an outlier. So let's jump right into the details. I'm just going to go through the file writes, the file writes to external media, and then the rest would be similar, and then I'll jump to the risk scoring. So what we can do is we have data from the file, right? And you can imagine that is basically a user ID and how much file writes happen to external media. We're interested in writes and copies. And we're going to aggregate this for each user and for each week. And for each week, we're going to sum the file size. This will give us the weekly file size. So this is just your base data. And we can sanity check what the weekly view looks like. So this is probably sufficient. Oops. And this is what the data looks like. We have the user, Janice Johnston. These are the timestamp, the weekly, the timestamp for the week, and the weekly file size. So we're going to do that for each week within our data. And then we can start thinking about baselines, right? We create a view for the baselines. And here what we do is we aggregate by user ID. We do a group by user ID and year, right? And for each year, we're going to compute the average and the standard deviation. That's your Gaussian model, your normal distribution, right? This is the model for that user for the file modality. I did include the min and the max value just as a sanity check, as a way to debug. So let's take a look. What does this look like? So for each user, it will have, you will have a year, the average size, the min size, max size, and the standard deviation. Now we're actually ready to calculate or detect the right anomalies based on the Gaussian distribution. And this is the view definition for that. And it's quite simple. We're really looking for this, where the weekly file size is greater than 3 times standard deviation on top of the average. And that's really all you need. So you're actually joining the weekly file behavior with the baselines, and using from the baselines to get the average and the standard deviation for that particular user. And we're using the previous year's data as the baseline, the previous year's baseline for the detection of this for this year. This is what the anomalies view look like. You see there's a user ID, the week, and the weekly file size. I put in the average and the standard deviation and the threshold, which is the 3 standard deviation on top of average for debugging. Now you're going to do this for email. You're going to do this for web uploads and for the print to hard copy events. Very similar approach. There may be small tweaks in how you would extract the event from the underlying data. But now we can actually jump to the risk scoring. And so what this does now is this, right? What we're going to do is we're going to take the anomalies from each of the modalities. We are going to count them, and we're going to do this for a particular time period, right? So suppose I'm doing it, the time at which I'm doing the scoring is 2021-0101, and the window for the scoring is 6 months. So I'm looking 6 months back from this date, right? So what I'm doing is this. I'm going to look at the anomalies for the time window, right? I'm going to count the number of anomalies in that time window, and I'm going to weight it with a particular set of weights. This case, I'm weighting file anomalies with 1.0. I'm weighting the email anomalies with 0.3. I'm going to weight the web anomalies with 0.5 and the print anomalies with 0.5. Union all these anomaly counts together, and note that they are indexed by the user ID and anomaly types and the anomaly counts. And we're going to massage it into a nice looking table that you see here. So for each user ID, I'm going to show the weighted anomaly score, which is your risk score. And then it's going to provide details on how do we get this score, right? So this gives you explainability. So I know I got this score because there was one file anomaly and one print anomaly. And of course, our file is weighted at 1.0 and print is weighted at 0.5. And this is how this anomaly scoring works. And so here we rank all the users by its risk score, anomaly score. And from here, you can set a threshold, say anything above 1.0 is flagged as an alert, where then a risk compliance officer can actually investigate and triage that. And of course, once you figure out what's the false positive and false negative, you can then go back and tune these weights to make sure that the scoring is more effective. Hope you enjoy this. See you next time. Thank you.